Okay, everyone, we're going to pick up where we left off yesterday, or today, if you're watching this tonight, on absolute value equations. So, we had left off with this one. Remember, there can be situations where you have extraneous roots and it won't work. So again, when we're solving this one, we're only concerned with the absolute value part to make our cases. So the first case is when the absolute value is the same, regardless of the symbols. So we would set it up like this. Case 2 would be the negative of the absolute value. So negative x minus 5 equals. Now this part stays the same always. It's just the absolute value portion that changes. So if we were solving this, we would move our x's over and put the 1 over on this side. So you're left with 6 equals 3x, or x equals 2. Okay? Over here, if I'm doing this one, I would add my x to both sides, bring the 1 across. So you're left with negative 4 equals 5x. And then you divide by 5. And you get x is equal to negative 4/5. So you need to try that and see if it works out, okay? So you need to verify that each one works. So if I was going to verify now, I would go up to the verification and say 2 plus 5 should equal to 4 times 2 minus 1. That would be the absolute value of 7 is equal to 8 take away 1. 7 is equal to 7. That's correct. Over here, if I'm testing this one in here, I'm going to have negative 4/5 plus 5 is equal to 4 times negative 4/5 minus 1. And negative 4/5 plus 5, we need to make this with a 5 on the bottom. And this would be negative 16 over 5 minus 1. That's going to leave us with 21/5. And over here, I would get negative 21/5. That can't happen. The absolute value of this is going to be 21/5, and negative 21/5 doesn't work. So the only one that works is our first value, x equals 2. Now there can be situations where you have no solution. Recall, absolute values can never equal a negative answer. So take a look at this question. I don't even need to really worry about cases right away because I'm just going to use inspection or common sense. If I rearrange this so that my absolute value is on one side, and I bring the 12 over to the other side, 9 subtract 12 is negative 3. Would you ever be able to have a situation where an absolute value answer was equal to negative 3? No. Absolute value is always positive. Positive. So this does not work. No solution. Okay, you should try this one on your own. Pause the recording here and try this one on your own. So, again, we come to this one, and through common sense, when I rearrange this, I'm going to get 2 subtract 9 is negative 7. We can't have an absolute value that's equal to negative 7, so there's no solution. To get some practice on that, you should now try some questions in the book on those two types. no solution type and an extraneous situation. Pause the video here to try those. Okay, our next two examples involve quadratic expressions. So again, we are still looking at two different cases. Remember, in piecewise, we have two different cases. Now, again, the case one that we're going to be looking at first is the same. It would be the same. So we'd be setting this up and solving it. Case two means looking at the other part, the negative version or the reflection part of the quadratic, the parabola. So it would be the negative x squared plus 2x equals 1. We solve each and then verify. So in this case, I'm going to move the 1 across. And this is not factorable at this point. So you need to use the quadratic formula. To get your answers. So you get two values for your x's. 2.41 and x is equal to negative 0.41. We'll leave the verification till the end. Over here, I do the same thing. This time I'm going to move my x squared over to this side. Now this time it will factor x minus 1 and another x minus 1. So my value is x equals 1. Now it's time to verify to see if this works, each one. There's two ways to verify. You can either plug these two values back into the original equation, or you could think logically about where the boundaries are. The point of no return would be on a graph. If you're a visual person and like to visualize that, you could sort of logically determine if that's acceptable. Okay? So we will do it by plugging it in. So it says 2.41 squared, and these are going to be a little bit rounded, minus 2 times 2.41 is equal to 1. All right? So 2.41 squared is equal to 5.8081 minus 4.82, and so that's going to give you an answer .99881. So we're pretty close because we rounded. If we had used the exact values, we can assume that that's right. It's fairly close. If we rounded it up, it would be 1. Now we also have to test our other value of x. So now I'm going to verify negative 0.41. So I put it into my equation. Minus 2 times negative 0.41, and that should equal 1. .1681 plus 0.82 should equal 1. And again, you get 0.9881 equals 1. So that's verified as well, fairly accurate. Now we also need to verify this one over here. So if I put 1 squared minus 2 times 1 should equal 1. Let's check to see. 1 squared is 1, minus 2 is equal to 1. 1 subtract negative 2 is negative 1. The absolute value is 1, so that works as well. So all three solutions work. So we say our solution is x is equal to 2.41, negative 0.41, and x is equal to 1. You try one on your own. Pause here and try. Okay, we'll do this one together as well. Again, you're looking at two cases, case 1, case 2. Case 1 involves the same equation. Case 2 is the negative of it. Bring the 2 across so it's quadratic. Bring this one across. Again, this one involves a quadratic formula, so use your quadratic formula here. You can leave it in exact form, or you can get the answers to be. X is equal to 3.56 and x is equal to negative 0.56. Over here, this one is factorable. X minus 2, x minus 1. So you get two values. Now we need to verify all four pieces in the original equation to see if it works. So our equation is x squared minus 3x, so we're going to try and that should equal 2. So 3.56 squared minus 3 times 3.56. And that's going to give me 1.9936. So that's good. We also check the negative, verify the other one. So negative 0.56 squared minus 3 times 0.56, and that should also equal 2. And again, I get 1.9936, and that is about equal to 2. Verify your other two over here. So I verify the 2 squared minus 3 times 2, and that should give me 2. 4 minus 6 is negative 2, which is 2. And we try 1 in there as well. 1 squared minus 3 times 1 should give me 2. 1 squared is 1, minus 3 is negative 2. Oops. The absolute value sign. 2 is equal to 2. Verified. All four answers work. That won't always be the case. Stop now, pause, and try this one. And then we have our final one where you have a little bit of linear and quadratic as well. No different again. We set up case 1 and case 2 of the absolute value. So let's set this up. Case 1. And we get the original. So, organize into quadratic form. A negative x and a negative 10x makes negative 11x, and we move that 10 over. So we can factor this, x minus 10, x minus 1. So our two roots are 10 and 1. We'll check those after. Case 2, we plug that in. And for this time, we're going to be using the negative version. Negative x plus 10. That's the only part that changes, the part that's in the absolute value. That's the only reflection part. So we organize our equation again. X squared minus 9x minus 10. It's factorable. X minus 10, x plus 1. So we get x equals 10 and x equals negative 1. We need to try each of these in here and see if it works. Let's try to do it mentally. 10 minus 10 is 0. 10 squared is 100 minus 100 is 0. This one verifies. 1 minus 10, when I try 1 in here, 1 minus 10 is 9. 1 is negative 9, which is 9. 1 squared is 1 minus 10 is negative 9. That's not true. So that one's out. Over here, if I tried it in case 2, 10 minus 10 works. We already tested that one out, and 10 squared, so that one's okay. And negative 1 minus 10 is negative 11, or 11, since it's the absolute value. Negative 1 squared is 1, plus 10 is also 11. This one works. So our final answer is x is allowed to be negative 1 and 10. Our solutions, those are the ones that will work. And you try one on your own. Pause the tape, try it. So, case 1 would be x minus 5 equals x squared minus 8x plus 15. Gather up your like terms. X squared minus 9x plus 20. That's factorable. X minus 5, x minus 4. So your two values are 5 and 4. Case 2 would have you looking at negative x plus 5 equals x squared, 8x plus 15. Bring everything together. X squared minus 7x plus 10. That is factorable. X minus 5, x minus 2. So your two testing points are 5 and 2. From here, you verify to see which ones work. So this one would work. This one would not work. We already know 5 works, so we test 2. And 2 works. Okay? And that's the lesson on absolute value equations. Thank you, and good luck with your studying. Hope you watch the video and everything makes sense. We'll chat again after the storm if you have any questions.